Pranay, we can start now.
Okay, so all the people have joined. So, all right.
Yes, let's go.
So, hello everyone. Welcome to another one of our weekly events, where we are discussing about a plethora of events ranging from metaverse, gaming, quantum computing, space, and whatnot. Today, we are gonna be having a discussion on the topic startups in semiconductor-based industries. GS Madhusudan, who is currently the CEO and founder at InCore Semiconductors, India's first processor IP company. He's a technological entrepreneur and system architect with over 30 years of global experience in creating startups, engineering device software and hardware products, managing R&D labs and technology product stage development. He's also actively involved in technological capability building for various government organizations, environmental issue, animal rights, and data privacy/security issues. So, we welcome you once again to our events. So, for those of you who are new to our server, Start Now is a community that was created in order to help young entrepreneurs develop successful startups through valuable guidance from our guests. So, feel free to ask questions to GS Madhustan sir. Just type in your name in the event chat section with the question. So, we'll be able to queue you, and you'll be invited to the stage. I'd also like to inform our audience that the recording for this session will be posted on our YouTube channel. So, without further ado, let's start the event with some questions that we people have cultured.
Okay. So, hello, sir. Is my voice audible? Hello. Hello, Madhusudan, sir. Sir, your voice is not coming. Like you can exit it again and rejoin it. That might solve the problem.
Audible now?
Yes, sir. It's audible.
Go ahead.
Yes, sir. So, our first question to you will be like, can you please tell us your journey and experience in the field of startup?
Okay. Long journey. So I have been in the industry for about 35 years now. I started my career back in 87. I did my first startup in 88. That was in Chennai. And very tough to do hardware startups back then. So kind of folded shop within like 3-4 months and shifted to the US because my job got shifted there. So basically, I think somewhere in 98, I left an MNC that I was working for and helped ramp up a startup out of Singapore. So after that, I've been doing a series of startups, mostly in the area of semiconductor design, embedded software, voice over IP, security. One startup we did on mobile phone design. We actually did a social media startup called keep fading the name Terawatt back in 1999. In fact, we had first called it MySpace, very similar to Facebook and stuff. So done about 8 to 10 startups, probably 1 or 2 successful. The others were all a little too ahead of the game. So I've piled up enough of expertise in terms of what to do and especially what not to do. And one of the things that I have learned the hard way was not to be too ahead of the curve. We did a bunch of very ambitious social media networking startups, medical health record startups, online shopping startups back in 99, 98. The problem back then was internet connectivity was very, very intermittent in this part of the world, right? Even in Singapore. So it was very tough to get those started up. Then I did a mobile phone startup, which is India's first company to design its own mobile phones as a ODM shop supplying mobile phones to other customers. We folded in 2 years again because no Indian company like Lava, Micromax, a whole bunch of companies back at the time wanted to design their own phones. It's changed now. Back then, they were just importing phones from China, right? So 2012, we folded shop. I joined IIT Madras to start a processor research group. When that work came to a bit of a fruition in 2018, May 11th, in fact, we started InCore with a couple of other members of the Shakti team. This is the Shakti Processor Research Group at IIT Madras. And InCore has survived for 4 years, is finally starting to get some customers and so on. And we are the only game in town. Doing a processor startup is not easy. It's very deep tech, has a lot of engineering involved. So not too many people started. But we will see where it goes. But doing a deep tech startup like this is not something I would advise young entrepreneurs, because it takes 5 to 6 years of R&D and development before you can even get a product, and VCs often, especially in India, might not have that kind of patience. But the semiconductor industry itself is giving new opportunities now, because based on the IP that we provide, this other open source stuff out of the RISC-V community of which we are a part. I think it's now time for young entrepreneurs to start looking at doing SoC startups. That is not doing the base tech, but doing application level chips for any number of verticals that is there in India. India is finally starting to consume its own chips, correct? So there is excellent scope across 8 to 10 verticals that I can think of. So that's been my journey so far.
So, being an electronics student myself, I would love to ask you how one should start their journey in this semiconductor industry.
You mean as a startup or just start to
As
work?
like how one should get into this industry, like after college, how one should pursue their path in it.
See, electronics is very simple. If you're talking about hardcore electronics, the only reasonable way to get into the industry is to make sure your basics are okay and that you can design stuff. Which means if you're going into analog electronics, you need to have capability to design RF amplifiers or power supply circuitry or audio amplifiers or any number of standard circuits that are there. Your basics should really be strong. If you're going into digital, then you can do VLSI design, right? You can get into chip design. Most second, even some third-year engineering colleges are part of the SMDP or related programs. So you should have enough tools and expertise in your college to build up that capability yourself. So if you get your basic design capabilities, your fundas correct, it's very easy to get a job at any of the MNCs or any of the local design companies, right? So if it's digital, you can easily join likes of Intel or AMD or Qualcomm or Broadcom or HCL or Tessol or Wipro or Tech Mahindra. If your design capabilities are good, and especially if you're on the RF or analog side, I can assure you, you'll get a job in 48 hours. And the salaries are pretty good. If you're a good RF designer, even as a fresher, you can ask for lakh 0.2 per month easily, even from a second or a third year engineering college, provided your capability is good, right? If not, salaries are still pretty decent. Good designers are very hard to come by. The mistake that every student makes is they don't get their basics right. You basically need to be able to design circuitry and demonstrate, and it's very easy to get components from any of your typical electronics markets like Lamington Road in Bombay or Ritchie Street in Chennai. I'm pretty sure Bangalore, Hyderabad all have this, right? Basic stuff, you're talking like an SMPS power supply, or you're talking about a small audio amplifier, or you're talking about a simple digital circuitry, right? But you need to get those basics right. You get that right, you will have a very rewarding career. And if you get into RF, which is designing things like Wi-Fi amplifiers or Bluetooth amplifiers, antennas, then there is even more of a demand, because it's almost a 1:10 ratio. I think for every 10 regular digital and other designers, you get like only one RF engineer. So scope is excellent. You're instantly employable, but not too many people put in the effort to learn the basics. They just learn some theories in college and then hope to get a job and are disappointed when they don't get the job. You don't need experience. I can assure you, if you get your basics right and you can show decent lab work, you will get hired at pretty decent salaries, even with zero experience.
Answer.
Thank you, sir.
So may I ask you like about the field of PCB designing? I mean, the thing that you're talking about is like the general circuit designing and all that stuff. So, but what if a person has to pursue a career in PCB designing or manufacturing as?
You can, if you're a good PCB designer, you get a job. The trouble with PCB design is it's kind of tough to teach yourself, right? As a fresher. So
Yes.
those are
Sir, actually, like I am like currently like I'm learning how to like design PCBs, and right now like I have like designed 2-layer and 4-layer PCBs as well on Altium Designer. So, so I mean, I want to ask like I mean, what is the like scope of this particular like branch in like the Indian market right now?
every major company will want PCB designers uh, badly. There's no such thing as enough PCB designers. The only thing is, a lot of PCB designers start in their career right out of diploma. You've done your engineering or you're starting straight out of diploma?
Sir, I'm actually in second year. I'm doing BTech.
Pardon me?
I'm in
You're
second
doing
year BTech.
The only thing is PCB designer salaries at the initial level tend to be on the lower side because you're competing with people coming out of diploma and stuff. Over a period of time, it catches up. Initially, you might find salaries to be slightly on the lower side compared to circuit designers. That's all.
Okay, so
It's not an easy job. By no means is PCB design. Just because the salary is lower doesn't mean the job is easier. Okay, PCB design, especially when you do complex RF design and stuff, is extremely complex, especially when you're doing some things like mobile phones and stuff.
the high-speed routing and all the impedance matching traces.
It's tough. I mean, ultimately, the circuit design translates to a good product only if the PCB design is done properly. You can approach me. I mean, there's no shortcut to it. Keep designing more and more PCBs and get somebody to validate it.
Oh, okay.
If you can,
sir.
depending on which city you are in, I'm pretty sure you'll have a company, catch hold of a senior PCB designer there and ask them to evaluate your work. It's as simple as that.
So through LinkedIn, I can just contact the PCB designers who are there in the company and just ask them. Okay, thank you so much, sir.
No, which city are you in?
Sir, I'm based in Delhi.
Delhi shouldn't be a problem here. There is enough, even catch hold of somebody in Cadence and stuff. They have a few things. Or actually, ST Micro has got huge facilities in Gurgaon or Noida. Even HCL has, right? So you should be able to find senior PCB designers. Just show him your work and ask him to critique it or ask him to do a couple of low-end jobs for free and stuff. There's no alternative to circuit design or digital design or RF design or PCB design other than doing design work. It's trial and error. You need to get your basics strong. Don't get me wrong, right? If you need to do impedance matching, you need to know all about inductance and why impedance needs to be matched and all that. Your theory needs to be strong to the extent that you need it for the job. But after that, it's design. There's no shortcut, no alternative.
Definitely, sir. So thank you so much, sir.
Yeah, Ayush, go ahead.
Ayush, you may ask your question now.
Good evening, sir. Sir, I just wanted to ask that why is there a shortage of semiconductors worldwide, and how is India planning to benefit upon it?
Unfortunately, we can't do much about it because we don't have fabs. We're MATI has a program for PLI for getting fabs, but the earliest fabs that will come probably will be earliest I can think of is 2026, last quarter or so, looking at some of the schedules. The reason the fab shortage came is twofold. One, because of COVID, a lot of the consumer electronics guys increased production. Everybody is working from home, right? Which means everything from headsets to mobile phones and those devices shot up because more devices were needed because people are working out of home. And what happened was, so the consumer electronics guys who kind of know the industry also started placing advance orders and I think locked up a bit of the capacity. This is just one of the reasons, right? There are multiple reasons for that. and because they are pretty savvy about it. The guys like the auto guys who are really not used to placing tons and tons of advance orders, booking capacity, and all of that, kind of got caught in this and did not book enough capacity. So that's why you're seeing a lot of auto majors either reducing production or delaying parts, delaying cars which have a lot of electronics. Like for example, like the XUV 700, which has got anything that has ADAS and stuff is delayed, right? You got waiting periods extending like a year and a half, which is like absolutely ridiculous. The other problem that happened was the auto guys, the industrial guys, all needed the older fabs, right? 65 nanometer, 40 nanometer, 28 nanometer maximum. And all these fab guys, if you look at what Apple is announcing, Intel is announcing, and AMD, right? They're all on the 7 nanometer, then the 6, and Apple and all those leading edge mobile phone chips are all at 5 nanometers because that's where a lot of the money is. NVIDIA also, right? Which chews up a lot of the capacity. So the fab guys did a lot of capacity expansion in the advanced nodes. And a lot of capacity was not added in the lower nodes, anything from 28 nanometer below, 28, 40, 65, 55, 90 nanometers, all of that. So, and the demand increase in the auto industrial happened in those older nodes. And so there was a bit of a capacity problem also. So if you actually look at something like 5 nanometers, it's actually easy to get, relatively easy to get capacity from a fab. But if you ask for 40 or 28, it can be a problem because there is a demand supply mismatch that has happened. It'll take a couple of years for it to play out. A lot of fabs are getting added, and my concern is that you're going to have a glut in fab capacity come 2025, 2026. We'll see. That remains to be seen. So it is a bit of a planning mismatch and also COVID skewing demand. So demand for a certain category of products shot through the roof, and the semiconductor industry is playing. It's just not only the semiconductor capacity, the packaging guys, right? It's called the OSAT industry, which does the plastic packaging, attaching the chip to the pins that you see, all of that, right? And testing. Those guys have not ramped up, and in a sub $10 chip, often the packaging cost can be more than the silicon wafer itself. And from what I heard, the packaging guys are deliberately not rapidly expanding capacity because they're getting higher margins and they want the good times to last, right? So I'm not seeing a lot of capacity addition happening in the packaging, but Tatas are coming in a major way, and I'm hoping that will alleviate the situation. So it's just not just when you talk about chip shortage, it's just not the silicon manufacturing shortage, it's also the packaging shortage.
Okay. Basically, the whole semiconductor ecosystem was not ready for the sudden increase in the demand.
Yeah, partly in COVID, partly in auto. There are multiple causes. I'm pretty sure when you post it on YouTube, 10 people are going to scream at me saying that your analysis is wrong. It was a combination of lack of planning. It's a combination of COVID adding increased demand. It's also a combination of EV vehicles coming and increasing semiconductor demand. Right? There's a variety of reasons why demand shot up. There simply was not an appreciation in a lot of industries that ramping up semiconductor capacity takes time and money. Right? A 5 nanometer fab to set up is probably in the $25 billion range. If you look at Intel's planned investments in Ohio and related stuff, it's about 100 billion. And with Samsung and TSMC also adding capacity in Texas, you're talking at least some $200 billion being invested in the US. 200 billion is a lot of money, man. Right? Not too many people can afford to invest that kind of money. My gut feel is by 2026, 2028, and if you add some of the newer fabs, the US is probably going to see anywhere from 300 to 400, maybe even $500 billion worth of investments. That's a lot of money. You're talking close to $500 billion just going into 5 or 6 fab sites. Very tough to match that kind of investment anywhere in the world. They're doing stuff in Europe also, but on a much smaller scale.
In India, I think Tata Group is also planning to enter semiconductor manufacturing in India.
In packaging, I don't think I know that team. Some of them, in fact, live close by. The Tata Group, if you look at I'm not talking anything confidential, is what they've announced, right? They've announced basically a desire to get into semiconductor packaging, not the wafer manufacturing itself. They may do that later. I mean, I'm not privy to what the Tata Group says. I'm just talking about what they've said in public. The investments they're talking about is essentially semiconductor packaging. The people who have announced an interest to get into semiconductors itself is basically about 3 companies. One is Vedanta, the other is, I think, Next Orbit Ventures, and I forget who the third one is. Next Orbit Ventures, I think, was talking about a 65 nanometer fab and stuff. The other 2 guys, I don't know whether they even tied up with the fab for technology. But there is a bigger issue. I think India needs to focus more on the older fab nodes. That is, you can have one fab at 28 or 22, but I think most of our fab effort should be in 40, 65, 90, 180, 350. Also specialized fabs like gallium nitride fabs for RF, power, silicon carbide fabs for high voltage stuff. All the EV guys need silicon carbide, right? Then you also have the RF analog fabs, because you need to do all your Wi-Fi, Bluetooth, 5G, all require RF amplifiers, right? They are very key to modern communications. That optoelectronic, MEMS. The advantage with these fabs is the ticket size is much smaller, anywhere from small things that 500 million going up to 2-3 billion. And you can actually end up putting about 10, 15, maybe even 20 fabs of the small kind, correct? The advantage would be then India would create an ecosystem of engineers who know how to install fabs, run fabs, all of that, right? That expertise is key. Currently, we have zero, other than SCL and some 2-3 test fabs here. We don't have fab engineers available easily, and it's not going to be easy to groom them. So the way you do it is you take older nodes, and there's not a lot of glamour in the older nodes. Probably profit margins are lesser. So a lot of the Western companies are abandoning the older nodes, or at least not focusing so much on that. Intel, I think, is trying to make a comeback. I think they've acquired Tower Jazz specifically for that. But there is a great opportunity for India to become one of the leaders in semiconductor manufacturing in the older nodes. And there's a great demand for that. A lot of the stuff that you do still is on older nodes. If you take your just a Wi-Fi light bulb, that's got a semiconductor. If you take your DC fan, like the Atomberg fans, right, that has a BLDC chip controller. Typically is like a 16-bit controller chip running a very small code, but it's still a full-fledged CPU. Similarly, anything in the BLDC motor, whether it be an AC, whether it be a refrigerator, right? All of them requires semiconductors, and all of them can make do with a 65 or a 40 nanometer fab. So there is no need to say that we need the latest and the greatest in India. We need to catch up with Taiwan and all that. Catching up with Taiwan and the US is a minimum of a 30-year journey. It's not a trivial journey, right? It'll take time. So we can't rush that up. So we need to play it slowly. The best way to get a foothold in the world market is to go after the older, the higher nodes, higher in terms of sizes, right? Which basically means 40 nanometers and above. Risk is lesser, good market there also.
Sir, I have a question. Sir, between 1945 and 2005, majority of the patents that were filed, like for semiconductor related stuff, was from USA and Japan. So, but still, China is the leading manufacturer. I mean, it is having all the fabrication and all that stuff like going on in China. So, I mean, why is this the case?
Why fabrication? I don't know. People have all of these odd notions about China. I monitor China quite closely. The Chinese government invites me once a year to give a talk in Beijing. Last time I went was December 19th to 22nd, right when COVID was starting. Fortunately, I got out in time. After that, I've been doing it remotely. People have all of these misconceptions about China. China is not a semiconductor manufacturing powerhouse. China does a lot of PCB design and manufacturing, but they're pretty good at that. That's why a lot of your phones, all of that get made. If you just go to my website, gsmadhusudan.in, I wrote an article on that, right? The myth of Chinese mobile phone components and stuff. If you take your typical mobile phone component, your CPU, memory, Wi-Fi, Bluetooth, all the regular stuff, they're all Western, European or Taiwanese, Korean. Even the Japanese are out of the market now, pretty much. Very little fabrication left, right? The Chinese components typically tend to be in connectors, some of the lower level components, maybe one or two power supply components, stuff. China has got the Xinhua, the group has been trying to get into manufacturing. SMIC, I think, manufactures all the way till 14 nanometers. There is one NAND flash fab, I think Yangtze Memory, which even Apple is considering using their product. They're not a leading power in semiconductor manufacturing. In fact, I think most of the capacity is not even in China. It's mostly, I mean, TSMC probably controls what, 30 to 50% of the world market and stuff like that. Now, Intel is ramping up, Global Foundries is ramping up, UMC. China does not figure. There are 2-3 Chinese fabs, and because the Chinese local consumption is high, those fabs tend to figure in the top 10 or whatever in the world. I've not looked at those figures lately. But chip manufacturing is not something that Chinese are at the forefront. They're trying, but you need a lot of Western tech to set up leading node fab, right? ASML out of Netherlands, I think, is a classic example, right? Those EU lithography equipment and some of the cutting edge chip manufacturing equipment is not easy to design and manufacture. So the West, along with Taiwan and Korea, are going to be at the cutting edge of semiconductor manufacturing, at least for the next 20 years.
So, but sir, like most of the components that we like see in the market are like from the Shenzhen market. Even I have just like heard this like floating around in the market, and even when I was doing this internship, so most of the components that were like imported were from the Shenzhen market. So,
What be specific? If it is a major IC, chances are it won't be out of
so
China.
like microcontrollers and like the normal like USB drivers and the normal operational amplifiers, optocouplers, and
No,
all.
those are very low end and non-branded stuff, right? If you take your typical microprocessor, right? Nobody uses the Chinese stuff. So if you take the standard ones, typically the leading players in the market are NXP and ST Micro, right? You also have Renesas, all the others. Then you have Microchip. Then you have Nordic Semiconductor. Expressive is out of China, and of course you have Rockchip and Allwinner out of China. But if you take any of the major components, they typically tend to be Western guys. It's only the no-name brand stuff where people are very cost sensitive tend to use the Chinese stuff.
So like for probably the Texas Instruments and also they are not doing the manufacturing in China. That's what you're saying.
AI, in fact, manufactures in the US. They have their own fabs and stuff. Very few people manufacture out of China. Chinese manufacturing typically is done by Chinese semiconductor companies. Why would you go to SMIC or any of the Chinese fab? They're not leading edge fabs. You would go to TSMC or Global Foundry typically, or Samsung.
Like for discrete electronics components, that's what I was like talking about majority. Like
Discrete is different. Very low, and India is also doing a fair amount, and India can actually ramp up in 2 years and do everything locally. Discrete is not a problem. I'm talking about higher end processes and stuff where typically China does not figure.
Okay, so China is mainly like into the like CPU market and all. I mean, not the CPU. I'm sorry, the PCB and all that stuff.
They are into PCBs. They're into the discrete component markets. They're into electronic design. So, for example, thermocouple. Like that. So even that, typically the way you do it is you would start your design with a Western component and switch to the Chinese for lower cost if you want it, right? So normal things like power supplies. So typically, I know of at least 1 or 2 Chinese vendors who give a clone of a typical TI power supply. It's pin-to-pin compatible.
Like the Chinese
right?
ripoff or something.
It's not a rip-off and stuff. See, you got to be fair to the Chinese. They're also pretty smart people and stuff, right? And they do innovate and stuff. I'm not talking rip-off. They're just providing a pin-to-pin equivalent component. That's all. Nothing wrong with it.
Okay, sir. Ankit, you may ask your question.
Okay. Okay, so I think there's an audience question. So Anushka wanted to ask, like, how is the government helping in semiconductor-based startups to grow in India? Is there any schemes right now which promote them?
there are two schemes that have been announced. One is a C2S where you can essentially apply for a grant that's been closed. I think on I keep forgetting February 15th or February 28th or something, 27th. Which is basically if you do a collaborative project along with academic institution, then they have I think a design linked incentive program which is still open, which you can apply for it. You can say that you're designing some IP or some other standard block and stuff, and you can submit a proposal, and they will help you with an appropriate grant and all of that. You can look up the scheme. That's run by CDAC. MIT has got enough on the web. So the C2S and the DALI scheme are the ones they're currently offering to semiconductor startups to get some initial money to help them out. Other than that, if you got a idea for something, you can also apply directly to MIT and saying that, hey, I want to do this chip, I want this kind of funding and stuff. They're pretty okay. And they have industry people who have quit industry, joined MIT to evaluate some of that. So you'll find actually technically qualified people in MIT, especially in the chip side and stuff, right?
Yes, sir. So, like, since semiconductor-based industries are like very big industries, so we require some great capital investment for that. So, how do we reach for that investment, or is there any way that we can bootstrap this idea?
That is a tough problem. It's a problem that InCore also faced earlier. But because we're kind of known in the RISC-V community, we got some bite out of VCs and people who wanted to invest and all that, right? But we didn't take any because they simply didn't work out. So if I can find it tough, and I've been in the industry so long, I'm part of a consortium, I advise the government, the venture capitalist guys know me and all of that, I can imagine the plight of a young person trying to do a startup. To cut a long story short, unfortunately, the venture industry is not well geared to fund semiconductor startups in India. MIT is trying, but MIT, the government of India alone can't solve the problem, right? You basically need venture capitalists to step up to the plate. Having said that, one of the problems is, the biggest problem in India when it comes to doing product-based startup, I'm talking only in the tech industry, right? Especially semiconductors, electronics, and all of that. We lack ability in product marketing, right? Every young person, even senior people who want to do a technology-based startup, looks only at the technology. They think their technology is great. All of that is fine, but please realize there are, keep forgetting, like about 7 billion people on this planet. The planet is full of smart people, and there are 1.4 billion or so people in India alone, right? So if you think you can outsmart somebody else, you got another thing coming, right? So have a bit of humility. Please realize that your product is if you have thought about a product, guaranteed two guys are already shipping that product, right? That is how competitive it is. I'm not trying to discourage you. All I'm saying is that don't rely just on technology as a differentiator when you do a product. Do your product marketing well, right? What product sells in the market, what is the price range, who is buying, why are they buying, and stuff. Some of the most profitable businesses in the country is like shops selling rice and wheat and stuff. It's as commodity as you can get. Why do they sell? Because they have good delivery, they've got wide variety of rice available, the customers kind of trust them. So they have built very successful businesses using absolutely commodity products where you can't differentiate from your competitor. I mean, your rice is only as good as the next guy's rice, right? You can't go around telling your customer that my rice is better than the rice sold by the shop 2 shops away. They focus on how to attract and retain customers, giving value to the customers. So when you do semiconductor startups, please focus on the product marketing. Why would this product succeed in the market? What can you do differently? Can you play pricing strategy? Never play a pricing strategy, by the way. I mean, if you say my product is cheap, that's the slippery slope to bankruptcy. Focus on value instead. For this money, I give more value than my competitors. Have better support, have better documentation, right? Be more flexible in dealing with customers, because a lot of companies tend to be a little rigid. So even if they got a great product, the customer says, yeah, but dealing with them is tough, man. I'll go to somebody who kind of understands my needs and kind of waits on me, right? So customer service matters significantly. So if you focus a lot on the non-tech stuff, then the chances of your semiconductor startup succeeding is greater. I mean, you might have created some very cutting edge stuff that nobody has, in which case it will be a pure tech startup, right? Forget this entire advice I gave you, just focus on that. But those tend to be pretty rare. Like I said, given so many smart people on the planet, for you to innovate and say that you're different from the rest of it is pretty tough. Because in semiconductor, to do that kind of innovation, you better be attached to a lab, right? Because the initial R&D has to be done in a lab. You have to burn 20, 30 crores before you get decent semiconductor tech. So it all depends on what you guys want to do. You have my contact. If you got an idea or something you want to bounce it off me, do let me know. Would be glad to help.
Okay, so thank you for that, for great suggestion.
Excuse me, sir.
Go ahead.
Yeah, I recently saw a post about RISC ecosystem. Like, could you shed more light about what exactly it is?
Okay. So till now, if you've seen all the processors, right? You had the Intel 8085, which became the 8086 family. Then you had the Motorola 68000. There are a bunch of other processors which all vanished. Then you had the PowerPC. And then you had ARM. The problem is, these are all instruction set. I mean, if you know how a CPU works, the CPU basically understands an instruction set. You write in a high-level language, the compiler translates that to assembly of that instruction set. That gets binary encoded, fed into the processor. The processor understands that language and runs it. But the problem is, all those instruction sets are proprietary. So if somebody wanted to create their own processor, they had to license that instruction set. RISC-V is basically an effort that came out of Berkeley. IIT Madras then joined them, was one of the, when the foundation got started in 2013. It's called RISC-V because David Patterson's group up in UC Berkeley is one of the oldest processor research groups in the world. Right? So they had a family of processors called RISC-1, RISC-2. This is the fifth iteration. You know the second iteration, RISC-2, I think essentially became Spark, Sun Microsystems and all of that, right? RISC simply means reduced instruction set. So the RISC-V effort basically out of Berkeley created an open ISA, which anybody could adopt. You don't have to pay royalties or patent or anything to anybody for using the ISA. You can basically do your own implementation, but using that standard. So in that way, it kind of competes with ARM and x86, where the ISA is not controlled by an individual entity. It's controlled by a non-profit foundation that anybody can join, contribute. So you can go tomorrow and build a RISC-V compatible chip and compete with NXP or ST or TI if you want, all right, in the RISC-V world. So RISC-V is basically an open standard, but it's also created an excellent ecosystem around it. There are also some few open source cores. Please realize there's a distinction between the actual implementation of a CPU and the ISA, right? RISC-V simply says the ISA is open. You have to do the CPU implementation. But there are entities both in the academia and in private sector which have created open source RISC-V CPUs, like IIT did in my Shakti project, correct? So that's there. So RISC-V essentially is a new ISA standard. It's an open standard. Anybody can adopt it. And it's kind of democratized CPU design. And we think going forward, I think RISC-V will become the dominant ISA in the world. How long it'll take that to happen, I don't know. But I'm pretty sure it's going to happen over a period of time.
So I mean this this RISC-V standard. So I mean, why is this? I mean, it is like more beneficial. Like, is it like having some specific applications?
No. It's an ISA. Like an ISA is simply add two numbers, like add register 1 to register 2 and put it in register 2, right?
Yeah.
That is so ultimately all computers need a standard language at the lowest level.
Yes.
The problem with all the existing languages, it's not that RISC-V is innovating in creating a new type of language, no. But it is innovating in the sense that the base instruction set is only some 32 odd instructions. Just it's documented in 1 or 2 pages. Everything else is kind of like an optional extra. So you can actually design a CPU to do just what you want. So it becomes very modular, flexible. So you can have more focused CPUs, correct?
Okay, sir.
Right. Just 30% for one. or in some cases you might want double precision, you may want bit manipulation. It all depends. So RISC-V has got a series of standard extensions. So you take the basic instruction set and you add whatever extensions you want, right? Kind of like a Lego block. But it also allows you to define your own instructions. So suppose you come up with a few instructions for audio processing. Say one of your customers is creating the next greatest noise cancelling headphone, and he wants a DSP, right? And he wants it low power because anything you put over your head wireless, the longer it lasts on battery, the greater the chances that the product will sell in the market, right? All things being equal. So you have to design a processor. You take the standard RISC-V instruction set, find it's not sufficient, you want to add 5 more instructions. You can't do that if you license ARM and stuff, unless you have what they call a architecture license and stuff, and those go into a few millions of dollars. But otherwise, whatever ISA ARM gives is the one you have to use, because for very valid reasons, they kind of want to maintain compatibility and all that. In RISC-V, you're not locked into that. You can go create your own custom instructions. It won't be compatible with other RISC-V CPUs, but as long as you control your compiler to generate those extra instructions, then you're safe. So it's that flexibility that RISC-V gives you, both in a technical fashion and in a business fashion, that is making it a very popular choice.
Okay, sir. Thank you so much, sir, for this. Sir, my next question, sir, I'm gonna be asking the question. So my next question is like, what are the government schemes that like entrepreneurs who want to like have a startup in electronics can take advantage of?
There are only two that I'm aware of, and that's mostly there is the DLI scheme and the C2S scheme. There is also one scheme for PCB manufacturing and stuff. And
Actually, that's what I'm like most curious about. Like, I mean, actually, I have seen that. I mean, PCB manufacturing is like not at all, I guess, done in India as far as I know. I mean, that especially the 4-layer PCBs, I guess. So
they do and I thought work and stuff are starting to do till 8. I've not been manufacturing a lot of PCBs off late, so I've not been monitoring the suppliers.
Oh.
But I think 6 to 8 layers probably gets done out of India. Out of anything more than 8 layers, because the demand is low, they will do it abroad.
So PCB manufacturers are present in India.
Yeah, there are.
Okay, because like majority of the manufacturers, like I have just like seen even on my LinkedIn as well. Like if I just like post a design or something, so most of the PCB manufacturers from China contact me and like.
Chinese are made into a fine art, right? So we are nowhere near where the Chinese are.
Okay.
But it's very easy to catch up with them. It's partly government policies, partly. See, the Chinese succeeded because there was a lot of local demand also.
Okay,
I mean, you can't make a military only based on exports. You need local demand also. The local demand in India is finally starting to come up.
Exactly, sir. I mean, like, for example, like JLC PCB and PCBWay, like, we can like give them the custom orders for our PCB and they'll just like get them manufactured like in small quantities. So, is there like a similar service available in India as well? Like, I mean, if you're aware about it.
Yeah, there is Power PCB up in Gujarat. I used to do all my PCB manufacturing out of them.
So, as a student, we can just give them custom designs and all. So, Gerber files we can.
Yeah. Give them a Gerber, they'll do it. There's also Peninsula up in Bangalore. Peninsula is in keep fighting. One of them is or high-tech PCB. There are small proto shops in Bangalore also. See, India may a lot of people do volume, but very few guys support the proto industry, unlike in China.
Okay.
Sir, based on that only, like somebody from the audience asked this question, like, is like China is going to is China going to impose a threat to the world and to us on the basis of reliability of chip production? Since like recently that happened, like India and China, like a war would have been done. So yes, sir.
But China doesn't figure in the supply of chips to India or to any other country here. So I don't know why people get so worried about the Chinese.
Okay, sir. So
I mean, there's a lot of this unnamed fear kind of stuff. In fact, I was just arguing with somebody in Twitter. Usual Russia, China stuff and all that, right? Our reliance on China is more on the problematic reliance is more in drug APIs, right? The base components that go into drugs and stuff. There's a government scheme for that, so hopefully we will reduce our dependence on China. Bunch of other stuff, but I don't think we rely on Chinese on anything strategic. It's more a question of laziness. It's kind of cheaper to do in China. Let's do it there types. It's not that we do it in China because we can't do it here. It's cheaper to do in China because uh, interest rates were lower, land was cheaper, a whole variety of reasons, and there is an ecosystem. It's exactly like Tirupur does knitwear, correct? It's a cluster got built up, not because of anything any government did. It kind of came on its own organically. So if you manufacture a typical garment, it will not be done in one place in Tirupur, right? One guy will do dyeing, the other will do some other processing, the third guy will do stitching and all of that. So you can, if you're a manufacturer, you actually don't have to invest in manufacturing facilities. You can subcontract that entire manufacturing process to a bunch of people, and those guys will actually deliver to the next guy and stuff. And the last guy will actually coordinate with whoever you designated as your shipper and drop ship to your customers. So you can actually even avoid having a warehouse. So Tirupur has got its act right in terms of knitwear. China has essentially done a very similar thing, but on a gigantic scale for electronics manufacturing. You can counter them, it will simply take time. But all I'm saying is it's not like rocket science.
Yes, sir. So somebody asked that is there any chance of setup of manufacturing unit of PCB raw materials, CCL sheets?
There are, it's a question of demand supply. It's a chicken and egg circle, right? Once this starts coming, see, one of the biggest PCB requirements is going to be substrates. You guys know what a BGA chip is, right?
Yes, sir.
So in a BGA, you actually see those little balls at the bottom of the chip, and you got a silicon wafer inside. But the silicon wafer typically is not connected directly to the balls. There is a small PCB inside. It's called a substrate. It's a very thin PCB. The shortage of substrates in the world is one of the reasons why chip production is also held up, right? So once people like Tata start doing packaging, they'll automatically start manufacturing substrates. Substrates are very fine precision kind of miniature PCBs, right? So as these things happen, you'll start finding that PCB capacity will get added in India. See, this is not a totalitarian country where somebody, Meiti or some part of the government can say, let there be 20 PCB plants and people will go build, right? The plants are all built by private sector entities. If they see a profit, they'll build. If they don't see a profit, they won't build. As simple as that.
Okay, sir.
So what the government will do, in fact, more than incentives, is to create demand. Once demand goes up beyond a certain volume, you will automatically find private sector investing in facilities.
Okay, sir. So there's a last question from audience that world is under the shortage of silicon. So what can be a good alternative to that? Or is there any way to come up with an alternative, or silicon is the only way to go?
Silicon is the only way to go currently. I mean, there are alternate 3-4 semiconductors and all of that, right? I mean, a lot of that is theoretical for specialized applications and all that. For the standard one, we're pretty much stuck with silicon. Nobody has managed to figure out how to do biocircuitry and all of that. I mean, a lot of that is almost in the realm of science fiction. So I'm afraid for the next 10 years, you don't have a choice but to wait for TSMC, Samsung, Global Foundries, and Intel to add to the fab capacity.
Okay, sir. So is there any reason why, why only silicon is being used?
No, there are electrical characteristics, manufacturability, and all that, right? So there are two reasons. One, technically, silicon makes sense, but you can also go to, I think, adjacent elements in the periodic table and stuff. I'm not a silicon manufacturing guy. But more importantly, for manufacturing, you should realize, right? Manufacturing people tend to be a very cautious lot. They tend to be a little conservative for very valid reasons. Because manufacturing is all about getting quality, very high yield and quality, right? Yield means if you manufacture 100 parts, 98 parts, 99 parts should be without defect, right? Defect rate allowed should only be 1.5% or so. So when you're operating at such high quality margins, you tend to have very rigid processes, because if you got too flexible of processes, you can't guarantee quality, correct? And so because it is so process intensive, that entire industry tends to be a little conservative, will not innovate beyond a particular point quickly. So even if there are technically good alternatives, I'm not aware of any, and I've not looked at it recently. Switching over is not going to be easy. Getting people to switch over from gasoline, petrol cars or diesel cars to electric itself is a nightmare, right?
Yes.
Human being resistance. It's very tough to change a human being quickly. So, as techies, you might think that all the world's problem can be solved with technology. Then you meet reality and you forget that the technology is the easy part. Convincing people to use it judiciously is the tougher part.
Okay, thank you, sir. I'll ask Shubhanshu to handle.
Thank you, sir. It was a really great session. We really loved the session, and I hope the audience is going to go with a lot of knowledge today. And we really hope to expect you to join us in a future sessions as well. And I hope you also enjoyed the session. Thank you for taking your valuable time out for us, sir. It really means a lot.
Yeah. And again, guys, I really apologize for the delay in starting. I had a mess up in trying to install.
It's okay, sir. First of all, we really thought we have to cancel the session, but eventually you showed up and the session was really great. And I would love to tell you guys that this session was in partnership with Singapore Hope Foundation. It was founded by Miss S. Mahi. She is in the Discord server as well. She is working towards a global cause, helping women. Thank you, sir, for your valuable time. And it was a really great session. We really loved talking to you. Thank you so much.
No problem. Glad to have you. Okay. Take care, folks. Have a good night. We'll catch
Good
up
night,
later.
sir.
Good night, sir. Thank you. Okay, guys. So this session was being recorded. We'll release the recording of that on our YouTube channel. So stay tuned with us. Stay tuned for next event too.